Hold on. Um, okay, there we go. Oh shit, fuck, I forgot to press the button. I'm actually killing myself. Okay. Okay, hi. Hi, chat. I'm so sorry. I'm so sorry, chat. Good God, I'm sorry. This has been a horrible, horrible mistake. Oh, Lord. Okay, well, I already lampshaded about this in the presentation that is on your screen now. So hopefully you all can find it in your hearts to forgive my horrible, horrible, horrible idiocy. Uh, God. Uh, I'm sorry. I'm sorry, chat. Oh, God. Okay. Welcome to Space Debates. Welcome to the first space debate that we have decided to have. Uh, uh, repost the link. Repost the link on Twitter, please. For the love of God, I need more engagement. Um, we are back. We are back. Um, okay. I've I have begun. I've begun. So, welcome to Space Debates. As you can see, I have a presentation up, and I am with Zoey today. Zoey, say hello to the audience. There we go. There we go. Okay. Whew. So, uh, this is what we will be debating today. But most importantly, why debating? Why debating? Why debate at all? So, you know how everything on Spitter devolves into a thousand-part horrible argumentative mess that ends up in the community ripping itself apart because nobody has like the actual time to articulate themselves? Okay, so what if we didn't do that? Welcome to Space Debates. If you have beef, you can come on here, talk about like whatever propulsion system you want to think is better, civilly and rationally. There will be moderators for future debates. This is just an attempt to learn, explore format. We're friends, so we're not going to be at each other's throats. There will be no insane things going on today. Today's problem will probably go a lot like IFT1. This is my first stream ever running a debating competition. This is actually my first debating competition ever. I've the reason I'm making this honestly is because my debate team just like I've pushed them for 3 years now and they still won't go to debates. So I got to get that college credit for my 3 years in somehow. So uh, welcome to Space Debates. All right, today's debate topic: SSTOs. The topic was originally provided by Aaron, and he had this awesome comment, and everyone loved it. I've changed it around a little bit. The current topic is whether a TSTO or SSTO is better for space exploration in general. Of course, we are going to be debating technological merits, etc. Uh, Forgot to post the "We Are Live" thing on Twitter. Okay, that's okay. Don't worry about it. I mean, to be fair, you're on an extremely niche internet micro celebrities live stream. Things are already pretty bad. Uh, okay. How will today be structured? There will be two overall debates: technological, economic. Each will be broken down into an opening statement, which both of us will get. It will be a max of 4 minutes. Time of exchange questioning, just 10 minutes total. Recess, which will just be like small break to reorganize, prepare better arguments, etc. Um, Questioning two, which will be 10 minutes total, and closing remarks, which will be 4 minutes each. That will be for each of the two. Oh God. So, all right, who's doing what? Representatives, we have Zoey as the pro-SSTO, and as the evil, villainous anti-SSTO man in the room, it is me, Perigee. But who wins? Who wins? This, of course, is the most important factor in the debate. There is nothing gained from the exchange of information. Nothing. There's none of that. The only thing that matters is who wins. And you decide that. You guys get to decide that. You can yell. You're the ones who get to tell us who wins. There will be a poll at the end of the stream, which I will link, and you can tell us. You can tell us who you thought won. Well, more accurately, I am genuinely concerned about this devolving into just like who is better BS in the future. So I don't I don't phrase it as who wins. It's more which position you think was better overall, and I think that's important. But it's gonna still turn it into a popularity contest if you want. All right, these are the rules for you. You, the audience listening here, these are your rules. Okay, no rage posting in chat. If you're just arguing with someone in chat, be civil about it. This means I would rather see long, incomprehensible strings of text rather than just, like, you're bad. Oh, well, I advanced too much. But yeah, if if you don't like either of our points, come on the show. At me on Twitter. And if any of you start another spitter war, I will be incredibly mad. All right, thank you. Uh, debate beginneth. Okay. No, don't. Just hide it. Okay. Hi, Spitter. So, welcome to the debate. I realize now that I forgot to prepare sufficient media for the debate, so you're gonna get stuck. You're gonna get stuck for the beginning part with a beautiful picture of. Here you go. You get NASP. There you go. All right, Zoey. For your opening remark, feel free to begin at any time. Let me get a timer up, and I will time you for 4 minutes. Whenever. All right. 3, 2, 1. So. When you look straight at the map, the SSTOs are not viable. It is simply a question of mass ratio, which is very doable. We decades been able to achieve the kinds of mass ratios that you need for an SSTO. For example, right here I have the proposed delta clipper between all DCX, which says that it would look at mass to a point to achieve 11 times 600 times growth mass. So the question is not of whether we can do it. Yep, turned you up already. Hold on. Sorry, hold on. I need to just do something here. They actually are right. You're not shut up, chat. Sorry, I will give you the entire time to redo that because it appears that the Discord window has been silenced. Okay. Okay. Zoey, can you say something again? No, they cannot. Okay. Here. Say something now.
Now can people hear me?
There we go.
I am talking.
There we go.
Yes.
Okay.
Awesome. Okay.
Okay, cool. Better. Why isn't the application capture working? Okay, so I'm going to restart the timer, and feel free to begin whenever you want.
Okay, so as I was saying before, I will restart. The question of technical feasibility about SSTOs is not really whether we can do them, because it is pretty clear that we can do them, and I'm loud, so while I talk, I'm going to turn myself down a little bit. It is, I think, the main question that needs to be addressed when talking about the technical feasibility of SSTOs is whether it is worth the effort to put in the design, so to put in the effort that would need to be designed an SSTO, and I think it is. So, if you're looking at Hydrolox SSTOs, which I think are the more reasonable ends, you can do Metalox. You shouldn't do kerosene SSTOs. If you're looking at those, they need to have, I'm using numbers from the Delta Clipper. It's a mass ratio of about 0.9. So if you look at that for Delta Clipper, that leads to something like a gross mass of about 590 tons, so that it can orbit about 11.5 tons of useful payload, which is, if you then take a look at Falcon 9, which has a gross mass, Block 5 has a gross mass of about 550 tons and can do about 800 tons. So, this actually surprised me when I saw it, because you can get, for a total vehicle mass, if you compare it with the kinds of vehicles that are currently flying regularly, you get not that much less of a total payload mass fraction, but you get all the benefits of having a single stage. So easier recovery, because you only have to recover one thing, and you can probably simplify all your ground infrastructure since you only need to fuel one vehicle. And it is. Oh my god, I forgot what I was gonna say.
All good. All good.
And yes, okay. So, and also, in technical feasibility, SpaceX has kind of already built something that could function as an SSTO, which is super heavy. We talk about it a lot as I joke about SSTOing super heavy, but the fact that SpaceX has built a stage that could reasonably, that could technically do single stage to orbit, and that was so far from the actual goal of it, shows that it is very feasible to achieve the kinds of mass fractions and payload fractions that you need for a single stage to orbit, even with slightly lower energy propellants like methane and oxygen. And that is, I know I haven't gone through all that my time, but that is pretty much all I have to say about that.
Awesome. 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 Phenomenal opening statement from Zoe, everybody. Everyone give her a round of applause in chat. Come on, let's get the applause up. Come on. Come on, guys. I need to see the clapping emojis in chat. Okay. I'm gonna get some water. All right. Now for the image I'm gonna use. Again, sorry. I'll give you guys a bit of time to recover and think between samples. He's a big guy. Okay, here we go. Right. And all right. We'll begin. Everyone is giving you love in the chat, Zoe, by the way. Okay. I will begin in 3, 2, 1. When debating SSTOs, the probability that you can make an SSTO out of anything should not exactly be the main point of contention. SSTOs are very viable from terms of material standpoints and have been for some time, even dating back to the 1960s with Robert Truax. What we need to debate, however, is useful payload, because while yes, on the 450 tons of hydrolox that the DCX, if upscaled, could theoretically bring to orbit, the problem is, with the second stage, that number becomes so much greater as to become almost comical as to why you would consider the first option. Now, Zoe spoke about SSTOing super heavy. The problem with that is, if one did SSTO super heavy, the problem is it would have such little useful tonnage to orbit that it would be functionally useless in space. Now, let's just say, for the sake of argument, that we get it down back to Earth. The problem is, well, that we can relaunch it and get it back to Earth. But the problem is, I think, honestly, on like it's less than 100 tons of what super heavy could bring to orbit. So for a useful super heavy in space, you would need to fly so many refueling flights that, while yes, could be like done within a matter of days, would be much more efficient if you had a dedicated second stage. This brings me into my first point. A dedicated second stage is not necessarily the greatest problem on Earth, because what you see when a stage is coming up from the Earth, the other stage, the first one, is already coming back to the launch site. With Starship, this lands on back onto the orbital launch mouth with 0 to no refueling. And the thing is, the second stage is still completing its mission for the entire duration. While that mission is going on, the first stage can be serviced, brought back, done anything it needs to in the same amount of time that it would take an SSTO, if launched, to get back. What I see here is that a booster is not necessarily dead weight or just complicating integration, as we've seen with Starship many times. They can integrate and deintegrate the vehicle many times in a single day. What it is doing functionally is boosting payload, and it is boosting payload in a manner that is not necessarily intrusive to the overall vehicle's design. We've seen many times that Starship is stacked, destacked. We saw Booster 10 be filled in, I think it was around 30 minutes. So it's clear that at some point it doesn't necessarily become too much of a hassle for the ground infrastructure. What we can say, though, is that because there are also two stages, more parts of the vehicle are interchangeable. You need to service the SSTO for longer. However, in that same amount of time, you could prepare the booster, load another ship, and fly another ship again. And that is, in total, the argument. The only other final argument I would say is preliminary attack on the idea of integration being the primary time driver. Integration and repairs are not the primary time driver. Even with the Falcon 9 first stage, reuse time only comes about to 9 days, which is a very low amount of time, and most of the remaining days are sitting around waiting for another stage. So I think, in total, the idea that integration is sufficient enough to warrant a massive payload drawback is very hard to justify. I'd also like to compare that even on the larger amount of fuel, even if, let's say, it was SSTO'd, the payload gain is astronomical. Booster can only bring around 11 tons expended, but for Starship as a whole, you can bring 150. And that's my time. Whew. God, I don't know. God, I don't know where I come up with these things. Okay. Round one. All right. Moving quickly in to questioning. Zoe, as you spoke first, you get the first question. So, there we go.
Okay. Give me one moment to think. I had a few in my head and I'm selecting one.
All good.
Okay. So, as it, I assume that everyone understands we're discussing fully reusable vehicles here, because when you're talking about the future of spaceflight and stuff that is sustainable and feasible, that is what you're talking about.
Mm-hmm.
How much more time and cost and effort does it take to develop a complete extra stage with very likely different kinds of reusability systems from whatever, like just completely different reusability systems from the other stage that you're developing. How much more time do you think how much the extra cost of effort and money and just time goes into that as opposed to developing one stage?
Likely a good amount more. However, development costs are justified by the fact that the additional payload will make up for it in no time, because you can fly more frequently. Well, not as frequently, and you can fly with more payload. For example, refueling flights. I think it was the DCY, I believe it took somewhere around 135 flights to fully refuel itself, whereas Starship only takes around 16. And that's if you're being extremely, extremely pessimistic. So, therefore, I would say that it's not the development expense will be paid off by the fewer number of flights that are necessary. All right. Feel free to respond on that.
I couldn't figure out my mute button.
Hmm?
Sorry, I couldn't figure out my mute button. I'm back.
Oh.
So. Oh my god, my brain just stopped working.
All good. We'll pause the timer. This is between friends. All between friends. Again, I do word vomit a bit. I apologize for that.
Yeah, I was collecting my thoughts while you were speaking, and then everything disappeared when I had to say another thing.
Ah, all good. All
Um,
good. All good. See, Chet, this is how you handle things properly. You don't be horrible. You don't be horrible to the other side, because we're friends here. We're normal people.
all right. Okay. So this is what I was. Yeah. So
Okay.
you were talking about the kind like refueling flights and the kind of the justification of the extra development cost and
Mm-hmm.
time and money and stuff
Yes.
through the payload game.
Yes.
I think um one thing that I'm going to point out about your argument is that you assume a just a fundamentally different a similar kind of architecture between the two,
Mm-hmm.
where you have a sustainable space architecture. It does not necessarily need to be the Starship
You've
kind of
fallen
architecture.
into my trap card. No, keep going.
Oh no, where you bring your payload up, and then refuel the ship and bring your payload where it eventually needs to go.
Mm-hmm.
If so, you're talking 135 flights to refuel a DCY, but the kind of architecture that you can do with kind of payload you can send to a useful location with 135 flights of DCY is so much more than like just by directly bringing your payload and maybe some smaller injection stages
Mm-hmm.
is, I'd say, astronomically more than Starship could bring in one ship with refueling flights, because even if the payload it can bring in one launch is small, if you're looking at just a massive number of launches like you will with any kind of futuristic space architecture, the amount it it still adds up to a large amount, even if a single individual launch doesn't carry as much.
Mm-hmm. Okay. Another question for you. For these transfer stages you're proposing, are these not exactly similarly hard to develop? Because they will encounter very similar problems to a second stage. I don't know exactly how hard zero boil off propellant management is, but I would say for an in space stage, it's incredibly hard, and if not as hard to develop as a heat shield. If I've misinterpreted your argument in any way, please tell me.
No, that yeah.
All right.
So
Keep going. Sorry.
that yes, that no, again with any architecture, you're eventually going to want to develop those kinds of technologies.
Mm-hmm.
So anytime you are thinking about transporting a lot of stuff to space, no matter the method, you're
Mm-hmm.
going to have to store propellant in orbit for a long time. And it's just a difference in talking about which kind of vehicle that you're going to be using to justify that development.
Mm-hmm.
Uh, and the thing is, if you are using something like an SSTO for an SSTO with a transfer stage, you don't necessarily need that kind of tech up front. You can
Mm-hmm.
start flying uh, and just use something like an upscaled Centaur
Yes. Yeah.
that doesn't necessarily have zero boil off,
Mm-hmm.
and you can do kind of an incremental thing. But if you look at an architecture that's more like Starship, well, you definitely can do an interim with no zero boil off like they are doing. You end up having to fly a lot more just because you're without that technology, you're losing a lot of advantages. Like it's you need like something like 25% more refueling flights. I think it was without zero boil off for Starship.
Mm-hmm.
So the it's to me it's about having
I'm gonna
a
pause the timer real quick
okay.
because I think we got a little bit off topic. I think we moved
Yeah,
from TSTO in general to Starship, and I
fair
apologize
enough.
for that.
Yes.
Let's
Yeah.
let's wind this back again. I'll add 2 more minutes back on the clock, so we will have 6 minutes left. Feel free to restart and whenever you're ready.
So am I just restarting on this same point about yeah.
Yeah, yeah. Just
Um
without the Starship rabbit hole. That's my fault too.
fair
I
enough.
shouldn't have brought it up
Fair
as
enough.
much.
Um
Hmm.
okay. So my brain went everything down the Starship rabbit hole.
All good. Same with me.
Um okay.
Right.
I'm gonna use some of the same point but less
Yeah.
connected to like the Starship rabbit hole with any kind of separate development because if you have a TSDO vehicle which you're using to get payload somewhere,
Mm-hmm.
you have to do all of that development up front before you can be up and launching payloads. Um, which is that's how before you can be launching payloads, before you can be bringing payloads to further orbits than like Earth orbit,
Mm-hmm.
because you need to do all your development up front. But if you have an SSTO, you can what you can do is have you can phase your development. You can start with just getting the bare minimum to get to Earth orbit, and then that lets you, you know, figure all your systems out, get used to everything, and maybe try to get more investment and stuff, and then as a next step to work on in-space transportation to get to further uh, destinations. So for me, it's about being able to. You can do this. You can do this to some extent with TSTOs, but there's a point where you can't quite develop as you are flying as much.
That's true. That's true. I'll give you that. There is a reason why Stoke started with the second stage. Um, in response to development times, I would say that again, there is of course opportunity cost. Opportunity cost is a very real thing, but I think that in the long term, developing a TSTO which allows you to bring more mass to orbit per year will set you up on a better path overall because again there will still be some expenses for a TSTO that will necessarily be over an SSTOs, but I would say that the useful mass that people will pay for in space will be more of a viable scenario than the SSTO, which again still requires much larger development to do the same things that a traditional TSTO would be able to do outright.
I'm again collecting my thoughts. I really should be writing stuff down as you're talking.
All good. Good. Actually, I will get a pen. I will get a pen and paper and do the same. Notepad, baby. All right. Whenever you're ready, Zoe.
Okay, so I have kind of I'm gonna shift a little bit because I think we are focusing a lot on development, but there's also a lot of good points to be discussed when we're talking about the actual operation. Because once you so about operation, you are pointing out that with really rapidly reusable TSTO systems like Starship, you can get similar reuse and cadence as an SSTO. But one thing I want to point out is that on a Starship flight, when you're talking about having the second
Mm-hmm.
or any TSTO flight, I know I'm trying not to go down the Starship rabbit hole.
It's all right.
Any TSTO flight, or when we're talking about reusability, uh, you have to have your teams doing multiple things at once. You have to have, guiding the booster. You have to have people monitoring the booster as it's guiding itself back to land. You have to have people watching the second stage as it goes into orbit. And it requires more people doing more operational effort at once during a flight, which then means that you cannot be flying as much. So, if you whereas if you look at an SSTO while it's flying, you are only monitoring, one vehicle, and so you need less people who are, in mission control, monitoring as it flies, uh, sending, whatever mission control people do to it,
Yes.
and so you can have more flights per personnel, kind of. That is what I'm saying.
Okay. Well, okay. So, in response to your point, which is largely about, if I believe I got this correct, mostly about the extended personnel costs required to run a TSTO vehicle. So, I would argue that this load may not be as great as we are assuming for both, because in recent years we've seen many, many more increasing steps towards automation. The stacking and integration of Starship is almost entirely automated. Um, Automated flight termination systems weren't exactly as big of a thing as they were quite a few years ago. That's just taking more and more people out of the control room. Well, yes, there will always be teams required. I don't think on the scale that we are talking about, two people versus one person monitoring both stages will be the complete and utter death of a program. I think still the advantages for a TSTO vehicle, again payload, etc., would still be greatly viable. Taking notes with a Crayola twistable. What does my life come to?
Um. Okay.
Cool.
So, I'm bringing it back. I know I keep kind of shifting, but you
Mhm.
keep saying other things that I want to address.
All good.
Again, going back to talking about payload fraction and payload per, mass of vehicle. And I don't think that it is necessarily. I don't think that optimizing specifically for payload mass fraction is the best. Oh, and my earbud just died. Can you still hear me?
Yes, I can still hear you.
Okay, good. I don't think that thinking about optimizing for payload mass fraction and trying to get as much payload for the mass of your vehicle is necessarily the best way or the way that is going to be gone about for uh, optimizing optimizing a system for like sustainability and being the best launch system. I know we keep bringing it back to Starship, but it is a great example of a lot of things. Like originally, they were talking about using carbon fiber to try to make it super lightweight, and then they shifted. Uh, they decided that taking the hit of payload fraction by shifting to stainless steel would end up being a better choice because it allows them to simplify. It allowed them to construct and refurbish the vehicle easier.
Mm.
And again, talking about refurbishment, there's even though you can be, with a TSTO system, a reusable TSTO system, you can be inspecting and refurbishing the vehicle the first stage while the second stage is, still doing its mission. There is still you still need to have separate systems and procedures and equipment to to refurbish your first stage and refurbish your second stage, and there's a limited amount of commonality those can have.
Mm-hmm.
So but and while there might be more things on an SSTO to service, like it probably ends up having more engines than a comparable TSTO system, there's a lot more commonality there since it is a single vehicle.
Mm. In response, I would just say you would be able to just fly another second stage instead of having the whole system taken offline for maintenance. That is the end of our time, and I think it is quite a convenient end of our time because I think we found the big topic for the
Yeah.
second part of the debate. So, we are now done with opening questioning one. We will take a small break for which we will both deafen on Discord and then say things into the void. So, uh, cool. 3, 2, 1, deafen. Cool. Okay, let's see. So, not going to be able to hear Zoe, I just realized. This actually might not be the greatest idea in the world, but it is an idea. So, chat, I'd love to get your feedback on what has currently conspired because I am noticing that the viewer count has dropped. But yeah. Yeah. Okay. So, okay, I'm just gonna outline my thought process just reasonably. So, separate systems. Hmm. Separate systems. I'd say that the main rebuttal you could use against that is commonality. Commonality. Um, Commonality between engines, etc. Like you have like you have with Raptor, but then you spiral into like the Raptor boost optimization without the gimbal. Uh, then of course there's the other issue of just optimization in general. You can optimize. You can optimize. Ooh, this is a good argument that I see it, Barack. Uh, you can optimize. You can optimize more on a TSTO than you can for an SSTO. Whereas for an SSTO, you just have to integrate everything all at once. Um, yeah, Cosmic Arc, I am reading chat on occasion. But yeah. Just send Zoe a message. Chat, unfortunately, I will not be. I can listen to your arguments. Chat, throw in some arguments for Zoe too. Come on. Come on. Come on. Alright. Some of you should be raging at me. Um, okay. So, let's see. Okay. Alright. So, position. It's actually, figured out a good point. Hmm. Uh, okay. 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 Well, I have some better arguments that I now have written again in green Crayola twistable if you want to roast me for that. Cause whoo, that's just sad. Uh right. Zoe is once again back. So, undeafen. Hi Zoe. Oh wait. Wait. Oop, she's still deafened. Okay. So, um hello Zoe. I cannot hear you.
Yes, I have fixed it.
Cool. There we go. Oh, sound a lot better. This mic quality is way better.
Okay, so maybe I should just use my laptop instead of my earbuds.
Okay. Oh god, that's kind of sad. Okay. Um, you got first talking. You got first opening last time. I get first opening this time.
Okay.
Um. Okay. In response to the discussion about more complex complexity being required, I would say that while that is true, there are very many ways you can mitigate that. On Starship, while yes, Raptor Vacuum is a completely separate engine, the Raptor C levels used are borderline identical to the Raptors on the Super Heavy booster. These are still share common guidance and control software, so I would say that some difference can be mitigated. Although I will admit wholeheartedly that is a full-on cope argument. Um, the other thing I would like to say is about replaceability. That well, yes, an SSTO is much is well, let's say an SSTO cannot be replaced as easily, is what I would like to say. Versus with expendable second stage, once you factory print that, it will be able to be made and replaced in much less time than it would. Well, not much less, some less time than it would take to create another SSTO of a similar caliber. Um, the other thing, in response to you saying stuff about this was a while ago, payload mass fraction may not be the best thing to optimize for. I would agree that payload mass fraction on its own is not the best thing to optimize for. But I would say that you do require a certain weight and a certain volume in order to make a launcher viable. For example, for like a completely dedicated human space program centered around one launcher, you need a certain diameter, you need a certain volume, and you need a certain amount of payload because, frankly, we are humans. We that defines everything that we do in rocketry. That all comes down to the basic requirement. So while yes, payload mass fraction is not the best thing to optimize for, you end up when you try to optimize for payload on an SSTO, you just get more and more diminishing returns. And I would say that that is a problem inherent to SSTOs. It is, of course, it is a problem that still exists on TSTOs, but it is very much mitigated by staging. Um, you can see this in like basic Atlas performance versus um, Atlas Centaur performance, for example. Um, the other thing I would like to say is optimization. TSTOs have this in spades. You can optimize for landing, and you can optimize for in-space use. I believe that the Raptor Sea Levels engine is ISP is around like 330 seconds at sea level versus the vacuum of somewhere around 378 currently. Because of that, I would say that because you can optimize more on a TSTO, it allows for much more dynamic space operations. Final thing, I have a little bit of time left. Because you're also proposing a tug-based architecture and in commonality with an SSTO, well, in conjunction with an SSTO, that also still requires more teams to man. So I don't think that adding one more team for the booster will necessarily be a giant expense. All right, there we go. That's the end.
All right. Also, before I start talking, I'm gonna say a funny joke, which is someone made a joke in the chat about a 5-stage orbit. I'm pretty sure that pilot, like Notsnick, was actually 5 stages. So fun fact.
Hmm.
So the worst way to optimize your rocket is to just add more stages.
Interesting. All right.
So also I think I've had people say my mic is better now, so that's good.
All right.
So in terms of talking about, I heard you talking a lot about designing each stage of a TSTO and like designing things with a specific application in mind. So rather than a kind of general purpose thing, and also I'm first going to address your mass and payload volume thing, which is there. It's all a question of scale. Yes, an SSTO that can carry Starship level payloads to orbit is going to be bigger than a starship, but I ultimately don't think the physical scale of a launcher matters a huge amount. I mean, unless you're going for like a really massive thing.
I'll agree with you on that.
So the I don't think there's any necessary barrier to making an SSTO that can bring the kinds of payload masses and volumes to orbit that you need for human exploration. If you go with the same kind of payload mass fraction as Delta Clipper, like I was talking about, something that could carry 100-ton payloads into orbit, and it would be very wide, so you would not really have any kind of volume constraint. That would be something on the order of 6,000 tons, and I can't remember how much the gross mass of Starship or Saturn V is right now. But it's not. It's it's when you get to scale. I think at a certain point you are going to need a massive rocket no matter what, and so the question of if it is a little bigger to accommodate the kind of payloads you need is not necessarily, it's not that important, because when you're on that kind of scale, scaling up is not that much more costly. And then talking about designing things for specific uses, like designing each stage for a specific use, you definitely do have a good point there. But again, when you are designing something for a specific use, that requires more more effort in both development and operation, because it is going to have less commonality. Like if because just by necessity, a TSTO is going to have less commonality than two SSTOs, because each stage is going to be designed for a different use. And so even if you like do the Starship thing and have a lot of the same kinds of components, there's only so much commonality you can get, and there's simply, on something of the same scale, there is going to be a not insignificant amount of separate systems that require different development and different operational effort.
Good. And coincidentally, right as your time ran out. Okay.
Perfect.
And now we begin the second phase of cross-examination. So now, you said that necessarily a TSTO will have less in common than an SSTO with another of its kind. However, I think that when you look into more of the manufacturing, an SSTO will necessarily be more complex in construction, because being optimized for one thing doesn't just mean that you have just your parts are optimized for only one thing. It means that you're able to delete a significant amount of complexity that comes with a single stage vehicle. Super heavy. Well, yes, it is a complex machine. If you've seen the inside of it, it is frighteningly stark. Whereas compared to something like NASP or Roost, for example, you need many systems that need to be made much more complex by it being an SSTO. Do you think that there's? Do you think that? I don't really have a question. I'm just. What is your response?
Um, Yes. So, I think what you were saying about having where you have each stage specified for a specific use, and that means you can simplify the design. I think it's a question of you're still, for both an SSTO and an TSTO, you need all the same systems, and it's ultimately just a question of how many vehicles are those systems spread across. Um, and uh, it is bleh, I totally forgot the words I was going to say.
All good.
Good. I'm so yes, spreading out the systems across multiple vehicles. You are right that the building of the construction of a single SSTO is going to necessarily be more complex than a stage of a TSTO. But I'm trying to think of how to phrase this.
All the time.
But ultimately, I think once you get to the point where you are able to develop stuff that is like that, futuristic rockets that are rapidly reusable and can have cadences of like hundreds of times per year, um, you're gonna be able to simplify a lot anyways, and ultimately you're gonna get with any rockets you get to the point where I know simplifying it a lot. I'm saying I'm simplifying it a lot, but you get to the point where each stage of a TSTO is basically going to be a brain and engines and tanks, and you end up just
Hey,
having
Zoe.
more of that.
Zoe, the echo's really bad on your end, I think.
Okay.
No,
Yes, that is.
actually, I think you're good. I think you're good. Sorry, keep going.
Um, yeah, it's. I'm gonna mute my volume on my laptop while I do this because I think that is the problem.
Okay,
So I will just unmute my volume when I'm done so I can hear you.
cool.
So what I was saying is ultimately you are going to have more of that kind of stuff with a TSTO because you have separate vehicles, and you just need more of those kinds of systems. Like you need two different landing software, two different kind of recovery systems, and while you definitely can simplify those a lot, there's still just more. And if you have more things, that ends up with more points of failure. Uh, so, um, yes, that is what I was saying. I was talking like I was going to get to another point, and I didn't have one.
All right, okay. Points of failure. Solid response. I have borderline nothing. Let's see. You're right. I don't much I can hit back with that I already haven't. However, I will hit back with this. If you are at all limited by cadence, I would say that a two-stage to option approach remains superior. The problem is, I'm going to critique my own argument. That limitation will generally be artificial, because an SSTO and TSTO are still capable of hitting roughly the same cadence. And again, I would still argue that being able to bring more into orbit per launch is still a very, very positive factor. The complexity that you do read into the design by having two separate stages is hard. However, it's time to hit back with a not great argument. In modern times, while SSTOs are still, oh god, I hate myself for saying this argument. This is a horrible argument. Okay. While SSTOs are still technologically viable, they are not technologically optimal. And because they do not maintain their ability to be completely optimal among almost all other options, I would say that because you are ultimately getting I'd say like more payload per dollar used to low Earth orbit with a TSTO system, that system would still remain superior. There you go. That's my argument.
So I think with the idea of what is optimal, that is something we end up talking a lot about in spaceflight because optimization ends up being important. But I don't think that it is necessarily. I don't think that the most optimal system is always the best. Just because when you have a if you look at a launch system that's optimized, that probably has the optimization tends to add complexity. Um, that is, what was I saying? Yes. Uh, okay. Optimization. But I had thoughts in my brain and I can't think of how to put them into words.
Good.
Yes. Okay. So if you're talking about, if we're thinking about the optimizing for mass of your rocket to um, mass to orbit and kind of optimizing different parts of your vehicle for different flight regimes so that they can be simpler, I think then you can go down a road of wouldn't having a second stage for intermediate altitudes be better? Wouldn't having a third stage for intermediate altitudes be better? Wouldn't having a fourth stage? And I think if you end up talking about just pure mathematical optimization, you end up with systems that are impractical, like a 15 stage to orbit. So ultimately, what you're talking about with designing a rocket is a balance of what is optimized but also feasible. And I think, in my mind, operations of an SSTO and TSTO system are pretty equally feasible because you end up canceling out the they kind of end up canceling out a lot of each other's disadvantages and advantages because they have their own disadvantages and advantages. But ultimately, I think when you're talking about feasibility of operations, especially because if you're talking about expendable, that's a whole other conversation. But if you're talking about future kind of sustainable system, you're going to be talking about reusable. So I think SSTO operations, I think, are probably more feasible than TST operations for vehicles of the same scale, because it's simply less stuff. And even if you have a single vehicle that's more complex than two vehicles, it is still one vehicle, which just necessarily removes a lot more systems like stage separation, like having to have your communications communicate with two stages at once. Like having, a sea level versus vacuum optimized version of your engines rather than something kind of intermediate or altitude compensating like an SSTO would have.
Mm. Okay, that's true. Where do you think that the most what do you think that should be optimized more? Factories or rockets?
I mean, ultimately, like with everything, uh, it is a balance because you could have a really efficient factory that
Mhm.
pumps out super complicated, kind of shitty rockets, or you could have a really awesome rocket that is like rapidly reusable and stuff, but takes 15 years to build.
Okay.
And so to me, the best kind of thing is an intermediate thing where you optimize your factories just enough that you're not compromising on the optimization of your rocket.
Okay. Well, what you made what you made earlier, you said like if you bring operational like viability to its end, you get 15, 16 stage rockets, stupid stuff. However, I disagree. When you are optimizing for things, you need to optimize for reflight time, business time, everything else. And what I think is by having a two-stage to orbit system, you are still able to optimize for time almost as effectively as an SSTO, and you are still able to like dismiss the like incredibly wild 15, 16 stage arguments because frankly that just begins to hinge on like integration time and other things such as that. Um, as as a thing, as part of my final argument that I'd like to make here. Well, final for this debate. There's still the other economic debate. Um, Fuel efficiency is one of the greatest things that is sought after in another industry, the airline industry. Um, it's not just like ground servicing time that's the problem, it's fuel efficiency. And as a result, like, as a result, of fuel efficiency being the primary driver, even a 1% efficiency gain in fuel is massive, massive cost and price wise over another vehicle. And I believe that rockets will share this trait of caring more about fuel efficiency, and the fuel efficiency overall for two or like ton of payload to tons per orbit is a massive difference between TSTO and SSTO systems. In my opinion, if you care at all about the efficiency of your system, then a TSTO system will be vastly superior, and specifically a two-stage to orbit system, because the impracticality of third and fourth stages ends up greatly disarming the SSTO. I believe that TSTO is the perfect compromise between the two because SSTO has too little of a payload fraction, and TSTO has a better payload fraction, while SSTO has a much poorer payload fraction, and therefore TSTO is more efficient because by staging you are reducing dry mass significantly, and thus you require less tons of fuel.
Yes.
Yeah.
Yes, that is true. I'm gonna address that, but you
All
are
right.
right. You do simply use less fuel. Um, but um, I'm gonna so when you're talking about fuel costs for rockets, and comparing it to, like you were saying, you were comparing it to the aviation industry. I was thinking while you were talking, right?
Mm-hmm.
So, to me, the core, I think that the problem is that in the aviation industry, it is fuel costs are a much higher percentage of the total costs of per flight, and then rockets, because for rockets, fuel is cheap, and even if you end up having a very, very efficiently produced rocket that can fly for cheap, um, I still think that fuel is not going to make up a massive amount of the cost, simply because any
Currently.
things like integration and handling. So, when you get to looking at the amount of fuel you're using, I think that only ends up being an issue if you're using a massively, massively more amount, which SSTOs don't really. Like I was saying, if you look at stuff in the 10 to 20 ton range, um, Delta Clipper would use something like 550 something tons of fuel, and Falcon 9 uses, which is in the same kind of class and gross mass range. If I can pull it back up, I had the page open. It uses, I think, on the same kind of scale, maybe like 50 or 100 tons less, which sounds like a lot less, but rocket fuels are really, really cheap. And so I think the ultimate concern with cost is not how much fuel you're using, but the actual price of your operations and your vehicle, which I think can ultimately be lowered both for operations within SSTO, just because you have a single vehicle, and even though that single vehicle has more complexity, there is just uh, there are just total less systems, because you can combine, everything gets combined onto one vehicle, rather than having to have things that deal with two vehicles at once and separating those. And with construction, it is easier to, even if it is on a larger scale, it is easier to mass produce a single vehicle SSTO than it is for two stages, because there's only so much commonality you can get between two different stages as opposed to a single vehicle. Yeah.
Alrighty. And that is the end of my time. Quite literally, just hit 0. Alrighty. That concludes the first of the 2 debates that we are having tonight. And now I am going to create a poll, and I'm going to inevitably wait for the results of the Zoey dub. All right. Here we go. Okay. Well, enjoy. That's the thing. You guys get to decide who won. So go vote. Go vote. We're gonna take a little bit of a recess here for a second or two. And then we're gonna get right back into the next argument, which is the economics. The
Which I
economics of SSTO versus TSTO.
have a lot of sources for this one.
Oh, okay. Okay, let's see. Who's winning? Who's winning so far? Okay. Alrighty. Come on, chat. Come on, chat. Get the results in. Round 1. Everyone is saying Perigee over in chat. Look at what you've done to me, Zoey.
No.
Zoey, you've killed me. Pin the live poll results to the screen. Oh god, how do I do that? Oh no. God. Live results. Oh my god. Oof. 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 chat. Okay. Settings embed. Oh boy, it's 50-50 right now. Huh. That
Oh,
is surprising considering how hard I got.
I had an early lead, but it's evening out.
Yeah. Yeah. Oof. Oof. All right. All right. Now's the part where I deploy my army of 10,000 bots, and I win. Just kidding. Uh, I couldn't do that. That would be mean. Uh, ugh, God. Let me get the results. Let me share results on stream. There you go, chat. Enjoy the live results. There you go. If anyone in chat wants to cast the deciding vote, their time is now. Your time is now for who's won. Come on, chat. The chat is perfectly divided. Oh, Zoe, did you just vote for yourself?
No, I thought I saw TSTO go up.
Oh, wait. Ha! Yes, I'm actually I'm very intelligent. You should vote for me. All right. Um and it appears the poll has decided although I think this poll is wrong. Okay. There we go. That is the end so far of the first debate. So now we move on to the second debate. Zoe, would you like the honors of going first?
Actually, I might put this one on you because I have one thing that I'm putting together.
Oh no, I'm getting annihilated. I'm gonna get annihilated. All right. Time for me to put the timer on. 4 minutes. And begin. In terms of optimization for potential costs across time, I believe that TSTOs have an inherent advantage. What Zoe has described previously as the complexities of maintenance in SSTOs and TSTOs, I believe can be overcome in around the same amount of time for for a TSTO. As again, you can automate many of the systems that previously would make reuse expensive. Now, previously Zoe focused on how fuel is not the main determining cost in spaceflight. And I would agree. It is not the main determining cost in spaceflight now. However, if we look at several examples in the airline industry, 8% efficiency increases in things like the A320 Neo drive millions of orders, thousands and thousands of orders. It keeps factories occupied. And SSTOs, again, by nature, they will consume more fuel to lift a given mass than a TS. God, words. Um, a TSTO will consume less fuel per unit of payload than an SSTO counterpart. And because, again, of how much these things, again, how much cost ends up driving things like the airline industry, and particularly where fuel costs are such a massive driver. I believe that um, the efficiency of the TSDO in reaching orbit is still very viable. And I also believe that while, yes, an additional stage is a bit of a pain to manage, with current technology, mainly meaning current engines, the ability to make a an SSTO that dominates ability to make an SSTO that dominates a TSTO in terms of unit of payload to orbit that can accept that loss while also boosting other factors of reusability does not currently exist yet. I believe that for the present and the future, payload mass to orbit will likely remain the predominant predictor of whether a rocket succeeds or fails in the launch industry. And that is my time.
Oh. So, oh, my computer is having a heart attack. So I'm going to start by talking about development cost, because I think that is a very important thing to address. So I really should have put this stuff into a slideshow, but I just have it in front of me, a breakdown talking about different development costs of each element of the shuttle. And looking at this, by far the most expensive thing to develop was the orbiter, which, makes sense, which constituted something like a full half of the total development cost. And so when you're talking about developing reusable spacecraft, it costs a lot to develop a single vehicle one of those.
Mm-hmm.
And while it takes more to develop, while there is more stuff that needs to be done to develop an SSTO, because it will have to be slightly more complex than an upper stage of a fully reusable TSTO. Ultimately, again, you are only developing one vehicle, and so you get to put your available development money into a single vehicle rather than two separate ones. And you focus when you run into issues, you can focus a lot more on them, because I keep coming back to the example of Starship, but they if you look at stuff like IFT-1, they couldn't even start testing the systems up to the upper stage, which they put so much time and money into developing, because they had systems with the first stage. They had issues with the first stage. And so when you are developing a launch system, ultimately it comes down to how much money do you have available and what can you do with that money. And if you can put that money into a single vehicle rather than two separate ones, even if they have a degree of commonality, you're going to end up with something that utilizes your development money better.
All right. Now we begin the second bit of questioning. Well, the first round of
We'll
questioning
also
for
say
this
that
one.
somehow it seems like in the intervening time, the vote for the first round may have reversed.
Let me check. Let's see. Who won the poll? Okay, so election fraud. Zoey stole this from me, and
I did not vote.
uh-huh.
I can screenshot and show
All
the
right.
has not voted.
Yeah, no, as chat, unfortunately, I'm losing, and yeah, it's Jover for me. As chat, as it's Perijover, as chat likes to say. Okay, back into the arguments. My first argument would be that dev costs are almost irrelevant to the future costs of a launch vehicle, because Falcon 9 is a great example of this. Dev costs get amortized so hard over time that it's not even funny. Falcon 9 cost around $3 billion to develop for the first flight. I believe that's actually an estimate for Falcon 9 and Dragon. But God, okay, chat's making me laugh. Okay. Dev costs get amortized over flights very, very hard. Falcon 9 costs around $3 billion to develop, and that's with Dragon. However, um, SpaceX made just revenue off of pure launch costs off of 50 launches. SpaceX made $3.7 billion off of launch revenue last year, which is frankly insane. And second of all, it proves that even with a comparatively minuscule amount of launches, as we're talking about here, you can recoup development costs down the line. Now, that is my take. Zoe, wait your response.
Yes, I'm formulating. Oh my god. I'm gonna turn off push to talk. Give me a second because I keep accidentally pressing the other button.
All good.
Okay. So, I do agree that ultimately the dev costs are not a huge player in the operation of a system. I do think that they are relevant when talking about the feasibility of a vehicle, but I will also now talk about launch costs, which, again, talking about reusable vehicles, a major, not, I mean, if you once you get to something that is sustainable and has large cadence and is rapidly reusable, you get to the point where the refurbishment costs, even though they're small, end up being a pretty significant percentage of the total cost of your launch, just because you've driven down all the other costs so much. So I think inherently TSTOs require more effort and cost in refurbishment because there's more things there. Because there are, again, in a TSTO, there are other systems that you need to inspect and refurbish. Like for 2 stages, you have double the amount of, tanks that you need to check for structural integrity if they, double check that they didn't spring a leak or crumple or something. You have stage separation systems that you need to check. A lot of the parts that you need to inspect and refurbish are duplicated because you have 2 separate vehicles. And so you're going to end up paying more to refurbish a TSTO reusable vehicle than you are with an SSTO, because the total amount of things that you need to inspect and refurbish adds up to less for an SSTO.
I'm going to. I have a point to make. I have a genuine point to make, but I am going to interrupt this with some happy news. Slim is alive. Slim has recovered. It is back online, and it is currently communicating with JAXA. So, round of applause for Jackson. That.
Oh.
Now we get back to the debate. How far in the future would you say that we are talking? Like, in respect to SSTOs and like inspections and that kind of cost?
I think ultimately we're talking about something that is pretty far down the line, because we're talking about, cadences that are hundreds of times per year, like beyond what we have with like just Falcon 9 now, and very rapidly reusable things. So I'd say on a scale of like
hundreds or thousands
what are you talking about? Hundreds or thousands what?
of launches.
Of launches. Somewhere in between that, I think for me, I'm thinking about, we're talking about a future in like the mid to late 2030s is what I was interpreting, because I think
if we are speaking about a time in the mid to late 2030s,
that was kind of an arbitrary thing, but to me it is something that is not near term, but not like super far term.
Okay, so can you reasonably prove that the benefits of an increased cadence over the next, let's say, like would the additional lowering of costs of a TSTO benefit over the payload capability of an SS of sorry, fuck, you know what I mean. Would the additional payload would the oh my God, can you prove that the God, I'm choking on my words. This is genuinely a Perigee moment. Uh okay. Can you prove that with launches scales in only the thousands that the integration costs of a TSTO would exceed its potential capability into low Earth orbit, or into any orbit for that matter, when we're just talking about a scale of thousands of launches, with hundreds to thousands.
I think yes, it's hard because it's very speculative.
Mm-hmm.
Once you get the kind of system that can launch on the scale of thousands of times a year, you probably are launching each, vehicle, whether it's, an upper stage and booster or just a single SSTO, you're probably launching each one a frankly insane number of times, like
Mm-hmm.
on the scale of 40 to 50 times a year.
Yeah.
And so you get to the point where build costs are not of each vehicle aren't irrelevant, but they became a much smaller part of the total costs of flying the vehicle because you're just reusing it so many times. And it starts to come down to your reoccurring costs on each flight. And I definitely think that integration becomes a much bigger issue with a TSTO than an SSTO because you can only make stacking stages so simple.
Mm-hmm.
Like Starship does it really well,
Yes.
but it still requires a lot of systems. It requires the chopsticks. It requires people going up and like inspecting it, which I know is going to simplify, but you still have a lot more to do with a TSTO in between flights than you do with an SSTO because you have all the same things that you need to do with an SSTO. When you're looking at the second stage, you
Mm-hmm.
need to integrate a new payload. You need to inspect, heat shield tiles or whatever you're using, stuff like
Mm-hmm.
that.
Yeah.
And then on top of all that integration stuff you have with an SSTO, you then also have to do it again for another vehicle.
Mm-hmm.
Even if you're looking at a TSTO and an SSTO in the same payload range, where the SSTO is physically much larger,
Mm-hmm.
the TSTO is necessarily going to have more systems that need to be integrated and repaired in between each launch. And so that I think adds up to a cost that is not easy to ignore.
Okay. My only current my only current rebuttal for that is just I'm not sure that when you're discussing thousands of launches for both that the costs associated with restacking, etc., will stack enough to matter. Because I will be brazenly apparent here. SSTO down the line is quite like obviously the future because like single vehicle stacking. However, I've tried to establish a specific time frame because both of us know that this is true. So in the future, this is a good note for in the future, we need to specifically establish a time frame. time frame. But yes, for on the order of thousands of flights per year, I don't think that I do not think that the additional costs associated with stacking will equate enough to thousands of flights of an SSTO. I need to be able to do math on that. That's a good question that needs to be answered. So, okay, for chat, the explanation for why I said I'm wrong here is if I'm wrong here is because I think that anyone with a mind can see that currently separating vehicles, like splitting them in half down the middle, well, yes, it's a perfectly safe enough system for now. um it's much like how you'd look at a horse and buggy. It's, oh my god, why would you put a wild animal at the front of that thing? Don't you know that that thing can run you off the road whenever it wants to? That's obviously how it goes. However, there's no argument if you're moving to the future, everything eventually will become an SSTO. But that's why I can't make a good counter argument. Again, if we're talking about a specific time scale and a certain number of launches, we can then argue. However, again, if we're arguing again technical complexity and spending, then what's the what's the thing here? So yeah, that's my current thought. That's my current thought. So yeah. Um I can't Here's the thing, chat. Um you can say that I should try to make an argument here, but the thing is, debates aren't about having a winner and defending a position to its death. Debates are often more about attempting to explain the logic and reasoning behind something, and when the logic and reasoning behind something is consistent enough for it to frankly dumbfound me, then I believe that there's no problems here in saying it, yeah, I need to look at that more. So if we have anyone in chat who would be willing to look into these kinds of launch costs, etc., that would be frankly phenomenal data, and I would love to look at that. So, yeah.
We need to
Um,
make space companies more open about the breakdowns of their launch costs.
100%. Please, if they took away the ISP from the data sheets, that is a crime that I cannot forgive. They don't put engine ISPs on it anymore, and it makes me mad.
Yeah.
Thank you very much. Thank you very much, chat.
We need. I'm
Oof.
thinking of who of the people who are good at figuring out niche numbers on Spitter we can ask about integration costs.
Yeah. Oh god, this was so fun. Oh god. I love this. Um yeah, I'll just say, things like NASP, which are air breathing and then go to combined cycle. I think if let's just, we're not having a debate anymore. We're just talking. Um stuff like that. I think switching over from scramjet to like would you say do you think that if switching from a scramjet to a fully combined rocket cycle, do you think that's less risky than just staging a vehicle or not?
I
What's
will
your
say
take on that?
that I focused entirely on conventional SSTOs and did not touch air breathing SSTOs
Yeah.
because I think there's a lot more ways.
Oh yeah. Yeah.
Again, if it also depends on uh time frame, but it's just there's only so much we can say about this stuff because there's only so much we know right now.
Mm-hmm.
I think right now air breathing SSTOs are a lot more iffy than
Mm-hmm.
um conventional ones
Yeah.
because
Here, let's get an example. Let's get an example here. I'll make a window share of like a here. Let's out here.
Yes, it's the weird one that looks like a giant dragon capsule.
Mm-hmm. Yeah. So that's why a lot of our yeah. Ugh, God. All right. Well, I think that was a pretty good debate. Did not end in a definitive conclusion. However, well, I mean, it did end in a definitive conclusion. Um, so I'll just say this: this is just a reminder to some people that picking the side in a debate is often infinitely more important than the speaking order. Which is a lesson I've tried to get through to people that they will not listen to. So, yeah, thank you guys. Thank you guys for being here. Thank you guys
Yeah.
for listening. We hit like 16 viewers concurrent, which is awesome for a debate stream. Oh God. So, yeah, thank you guys. Thank you for being here. And I will end the stream very shortly. Chat, if you have anything you'd like to say, I'd love to hear it. If it's just like beating me to death, I'd love to hear it. Yes. Quite some of you are mean. But yeah,
I see a good suggestion for a future one, which is space tug small sat launchers.
Oh, that's beautiful.
Hydrogen
That's
bomb versus coughing baby. That's what that is. That's what it is.
Oh God. Oh. All right. Already establishing your position. Felt like there was a big switch up between looking to full usage of systems and then to TSTOs being obsolete. That's true. That's true. I would say that that's mostly an issue of framing. Would you agree? Like, because the thing is, it's like in the future is very nebulous. We need a like a defined situation. Like when you have a question like this, you suddenly have a much bigger question is okay, so what's gonna go on, like what's happening during this time. So that's I don't know, that's the thing, that's the yeah. Zoe kind of annihilated you. True. It's not like
I did not think I was doing good in the moment.
no, you did very well. You hit me very hard. Um Again, remember, this is not a personality contest. Either one of us could have taken either position, and it doesn't say anything about the people involved. Just
Yeah,
again,
if I took TSTO, I would have lost harder.
like yeah. So just remember, we're all friends here. We're chilling. This is fun. That is what debate between us is meant to do. And when debate is not fun, that's why you get a moderator. You are absolutely correct. In chat, Zoe was absolutely more prepared for initial arguments. I was focusing more on like running the logistics of the stream that I kind of forgot that I was debating. So
Yeah, in the future we need to have someone else running the stream.
yeah, 100%.
Especially because it feels like every time we have a new stream, OBS and YouTube find another way to screw us over.
Yep. God, iterative testing, but for streaming on
Eventually we'll
YouTube.
get there.
God. All right. Yeah, I think we're gonna head out. Zoe, anything else you want to see to chat?
Nope.
All right. Thank you very much. Thank you very much, guys. Thank you for sticking around. All right. See you guys later. Bye-bye.
Bye, everyone.